Now that we know differentiation gives us the slope at a point, let's look at how to actually differentiate. To do this, we've got two methods, the long method and the short method. Let's break them down. The long method is only used when you're specifically asked to differentiate using first principles or basic principles. Very important. Only use this method when the question explicitly tells you to, because honestly, it's a mission. Way too much work for normal use. For this type of differentiation, we use the limit formula. The short and sweet of it, it helps us calculate the slope at a specific point on a graph. That's why the formula includes a limit where the gap between the two x values shrinks to 0. What does that mean? Think of the gap as the tiny distance between two x values. As that distance gets smaller and smaller, almost 0, the 2 points move so close together that they become one single point. And that's when we get the instantaneous rate of change, also known as the derivative. You don't need to stress about how every part of the formula works. Your only job? Know how to use it. And the best part? It's honestly super easy once you've seen it in action. Let's do an example together, step by step. First off, when we look at the question, we can spot the words first principles. That's our clue that we need to use the long method. In other words, we have to differentiate using the limit formula. To use the limit formula, there are two things we need to plug in, f of x and f of x plus h. We already have f of x. That's just the original function from the question. So our first step is simply to substitute it into the formula. The second thing we need is f of x plus h. So how do we find that? Well, here's the trick. In function notation, whatever's inside the brackets gets dropped into every x in the original formula. Wherever there's an x, we now just drop in x plus h. Everything else stays exactly the same. Now we just plug that answer into our limit formula. Now simplify the top of the fraction as much as you can. Next, we need to actually take the limit. Important. If you've forgotten how limits work, please go back to the video where we explained how to calculate limits algebraically. We're now going to try substituting 0 wherever there's an h. When we do that, we end up with 0 over 0 as our answer. Remember, when we get 0 over 0, that tells us we need to factor. Looking at the top of the fraction, we can see there's a common factor of h, so let's factor it out. Now we can cancel the h on top and bottom, and with no problems at all, we can plug in h equals 0 again. And boom, we're done. We've officially differentiated. And that brings us to the end of the first long method of differentiation. So quick recap. If a question asks you to differentiate using first principles or basic principles, you must use the long method, which is the limit formula for differentiation. Now, the second method we use is called the short method of differentiation. Very important. We always use the short method when the question doesn't explicitly say, use first principles. So how does this short method work? To do it, we use the anti-clockwise circle trick, an easy and powerful shortcut for differentiating quickly. Let's go through the second short method step by step. For this method, we use the anti-clockwise circle trick to differentiate quickly and easily. To use this trick, we always start right at the top with the power. Then, moving in an anti-clockwise circle, we take the power and multiply it with the coefficient. Just a reminder, the coefficient is the number, including its sign, that's attached to the variable, like the x. The final step to complete the circle is to go back to the power and then subtract 1 from it. And that's it. You've differentiated. Let's see it in action with an example. We're going to differentiate 3x squared 5, and since they don't say anything about first principles, we can use the shortcut circle trick. We start with the power, which is 5. Then we multiply it by the number stuck in front of the x, so 5 times 3 gives us an answer of 15. Now to complete the circle, we go back to the power and subtract 1 from it. So in our example, that's 5 minus 1, which gives us 4. And just like that, we're done differentiating using the circle trick. Let's look at the next example. In this one, we can again see that they didn't use the words first principles, so we're going to use the short circle trick method. In this example, we can see that we now have more than one term, not just a single term. All we do then is apply the trick to each term separately. Each term gets its own circle. All right, before we can apply the circle trick to each term, we need to make sure that every term is in the correct form. This means each term must have an x, a power, and a number stuck in front of the x, known as the coefficient. Without these three parts, we can't properly use the circle trick. So if we look at the first term, we'll see that it's missing a coefficient. In maths, you need to remember that if a letter doesn't have a coefficient in front of it, it actually means there's a 1 there. So we add that in. The second term is missing a power. Again, in maths, if a variable doesn't show a power, it means the power is 1. So we add that in too. The last term doesn't have an x at all. That means it's actually x to the power of 0, so we add that in as well. Now that all the terms are in the correct form, we're ready to use the circle trick on each one. So as we start with the circle trick, we take each power and first multiply it with its coefficient. When we do that, these are the answers we get. The next step to complete the circle is to subtract 1 from each power. When we do that, we get the following answers. All that's left for us to do now is to simplify the answer. And that's it. We've successfully done the differentiation. An important thing to notice here, something that's going to make your life much easier when it comes to differentiation, is this. If a term doesn't have the variable, the letter that you're differentiating with respect to, you can just throw that term away. Why? Because it's going to become 0 anyway. So next time you differentiate and you see a term without the variable, save yourself the effort and just ignore it. It's gone. For those who were paying close attention, you'll have noticed that we used the exact same example for both the long method and the short method, and the answers turned out exactly the same. Winging calculus is like winging a parachute jump, fun until the ground shows up. Ditch the 30 open YouTube tabs at 2 a.m. trying to integrate and grab my ebook course, step-by-step fixes and shortcuts. Cheaper than your monthly coffee bill and way easier than explaining a flatlining GPA. Course link in the description. If this helped, smash like and subscribe. See you next time. Cheers!